In this video, let's look at what are scaling laws for AI. So this is an interesting blog from NVIDIA. So here it talks about how scaling laws drive smarter, more powerful AI. So scaling laws describe how the performance of AI system improves as the size of the training data, model parameter or computational resources increase. So what are these three scaling laws? So one is pre-training scaling, the next is post-training scaling, and the last is test time scaling. So you have compute over here, you have intelligence. So more compute you put into each of these three categories, you get higher intelligence or performance from AI systems. So what is pre-training scaling? Pre-training scaling is nothing but giving more data to your AI system. Obviously, when you give more data, you need more compute resources. Okay, so that is pre-training scaling. So let's quickly look into what is pre-trained scaling. As I told, pre-training scaling is like you need more data, higher the model size or bigger the model size, you need more compute. So per pre-training data, scaling law, okay, pre-training scaling law, when larger models are fed with more data, the overall performance of the model improves. To make this feasible, obviously developers must scale up their compute. Okay, so this creates a need for powerful accelerated computing resources. Now from this principle of pre-training scaling, you got large models like your transformer models, mixture of experts, and these models had billions and trillions of parameters. Okay, so this is the pre-training law, and this law is still relevant because as we continue to produce a large amount of multimodal data, you have more text, more images, more audio, more video and sensor information which will be used to train powerful future AI models. Okay, so this is the pre-training scaling law. Now what is post-training scaling? So you have trained a pre-trained a large foundation model, but then it doesn't adapt to your needs. Okay, so there is this organization or something like a llama or something like a initial GPT-2 or something, right, where an organization releases a foundational model, right, but then you need to further fine tune it on a domain, okay, for your applications. That is what is post training process. Okay, so post training techniques can further improve a model specificity and relevance for an organization's desired use case. Okay, so you can think of pre-training is sending an AI model to school to learn foundational skills. Post-training enhances the model with skills applicable to its intended job. Okay, so that is the idea over here. So how do you do post training? You do fine tuning, you could do distillation, you could do reinforcement learning, you could do some other things like best of n sampling, search methods, right? Now the post training law says that a pre-trained model's performance can further improve in computational accuracy, in computational efficiency, accuracy or domain specificity using techniques including fine-tuning, pruning, quantization, distillation, reinforcement learning and synthetic data augmentation. Okay, so this also requires resources. So this is your post-training scaling law. And what they're saying is that to develop an ecosystem of derivative models for a variety of use cases, it could take around 30x more compute than pre-training the original foundational model. Okay, so you want to enhance the foundational model on various other domains. So this is the kind of compute resources required. The last is what we are hearing of late, which is test time scaling. So LLMs generate quick responses to input prompts. Well, this process is suited for getting right answers to simple questions. It may not work well as when user poses complex queries. Okay, so now you have this agentic AI workloads, right, where the LLM has to reason through the question before coming up with an answer. It is something like how humans think. We break a problem into smaller problems and then try to solve it, right? So test time scaling, also known as long thinking, takes place during inference. Instead of traditional AI models that rapidly generate a one-shot answer to user prompts, model uses this technique to allocate extra computational effort during inference, allowing them to reason through multiple potential responses before arriving at the best answer. So this is test time scaling, and this is what has led to the development of all the new reasoning models like DeepSeek, OpenAI O1, OpenAI O3, right? O1 mini, O3 mini. So these are reasoning models. Okay, so the AI reasoning process can take multiple minutes or even hours and can easily require over 100x compute for challenging queries compared to a single inference pass on a traditional LLM. Okay, so this is test time scaling law. Okay, so this test time compute capability enables AI models to explore different solutions to a problem and breaks down complex requests into multiple steps. Okay, and it can show the work to the user as they reason. This is the idea of test times scaling. So what are the approaches over here? Here you have chain of thought prompting, which is breaking down complex problems into a series of simpler steps. Right, you have sampling with majority voting. So basically you can generate multiple responses to the same prompt and then select the most frequently recurring answer as the final output. You can also do search, which could explore multiple paths in a tree like structure of responses. Okay, so this is about test time scaling. Okay, and this test time scaling is what is currently enabling AI reasoning. Okay, your AI reasoning models make use of this test time compute or test time scaling. Okay, some other use cases are explained over here, so I would not go into it. So these are the three laws of AI. Okay, scaling laws of AI. Right, you have your pre-training scaling, post-training scaling, and test time scaling. So you can think of pre-training scaling is what you do to get a foundational model. Post-training scaling is the additional compute or extra compute required for fine-tuning a model. And this is, test time scaling is actually the extra compute required to generate inference using something like chain of thought prompt or long thinking. Okay, so as more compute increases, as more data increases, more compute is required in each of these three stages. Okay, and as you give more compute, the performance of the AI is expected to improve. So these are the three scaling laws of AI. Hope this video is useful. If you like the content, please subscribe to the channel. I'll be putting the link of this blog in the description of the video. Please check it out.